I hope this is an easy section. In this section, we're going to use Venn diagrams that are filled up with numbers or letters and use the Venn diagrams to answer unions, intersections, and complement questions. The problems are easy, but that being said, if I don't make a mistake or two or four during this video, I'll be surprised because it's very easy to make mistakes when you're starting with Venn diagrams that have a bunch of elements in them, and then you're trying to answer questions about the picture. So anyways, I'm just going to jump right into this. This is the first problem. I'll do it with you. Here's a Venn diagram. It represents the universal set, a set called S, and a set called E. And all I'm asked to do is to write the elements of each set down. So first I'm going to write the elements of set S by looking inside the S circle. And inside the S circle, there's four numbers. Those four numbers are going to be the elements of set S, namely the numbers 1, 4, 9, and 16. I didn't need to write them in ascending order, but it just kind of felt good to do that. Next, I'm going to look at the E circle. Any number inside the E circle, which I'm highlighting in what's supposed to be yellow but looks more orange, is going to be part of the E circle. I think E means even. S means squared because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And if I look at the E circle, there's the number 2, 4, 6, separating the numbers with a comma, 8, 10, 12, 14, 16, 18, and 20. Kind of went over my limit here. So that's the E set and the S set. The universal set is any number that's in any of the part of this picture. All the numbers in the circles along with all the numbers in the rectangles. I think, let me just do them one at a time. There's the number 1, 2. I think it's all the numbers between 1 and 20, but I'm just going to mark them off as I find them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, so fun to watch. 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So 11 all the way through 20. How about I get lazy and go dot, 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 comma, 20, saying this pattern continues going up by 1 and it stops at 20, rather than listing what I did. Even when I wrote the answer down, I wrote 1, 2, 3, 4, dot, 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 18, 19, 20, not having the desire to write down all the elements of set U. So the first 8 problems are exactly going to be that. They're going to give us Venn diagrams that have sets labeled, and we're just going to be asked to write down the elements of all the sets that are described with that particular Venn diagram. I'm going to flash up set question 3, which is a friendly one. And instead of the universal set giving the letter U, it gives the letter Z, which is I guess a Roman numeral. But let's just call this U. So this whole set gives me the letter U, and you're supposed to write down the elements of set A, the elements in set B, and the elements in the universe. And if you want to check your answer real quickly, for A, I had that set. For B, I have that set. And for U, I'm going to have the letters from A through I. So you should be able to do that, hopefully, without too much effort. In problem 4, I copy and paste these things from the internet, and I couldn't find universal sets with the letter U for whatever reason. Let me change that to a U. Let me write down what set A is. Set A is any of the numbers in the set A. Looks like 1, 2, 3, 4, and 5. So set A is going to contain the numbers 1 through 5. Set B would be any number inside the B circle, and they're the numbers 3, 4, and 6. And the universe is any number in anywhere here. I'm going to go in order, starting at 1, and then 2, then 3, 4, 5, then 6, 7, 8, 9, 10. And that would be the whole answer for question 4. Question 5 gives me what looks like the numbers from, oh gosh, what's the smallest number I see? I see 4 is the smallest number, 19 is the largest number. I think it's all the numbers between 4 and 19. And again, this universal set was labeled with that as opposed to a U. But in this case, you have to find out what set A is, what set B is, what set C is, and what the universal set is or contains. And the answer that I have for number 5, A looks like 4, 6, 8, 10, 12, 14, 16, 18, multiples of 2. B looks like multiples of 3, 6, 9, 12, 15, and 18. C looks like multiples, well, it doesn't even look like multiples of 5. I have 5, 6, 10, and 15. And the universal set U looks like the numbers between 4 and 19. I'll do number 6. You can fast forward and not watch me do number 6 if you don't want to. Again, I'm going to change this Z to a U just to be consistent with myself. So first I'm going to find the elements of set A. I look at the A circle. There's 4 numbers in it. There's 1, 3, 4, and 5 inside the A circle. So set A represents 1, 3, 4, and 5. I'm going to move on to set B. Set B has 4 numbers in it. I'm going to write 2, 4, 5, and 6 in for set B. And then lastly, I'll work on set C. Well, second to lastly. For set C has 5 numbers in it. I'm going to go 1, 5, 6, 7, and 10. And then I'm going to work on the universal set, which is any number in any of the sets. I'm going to start at 1 and work my way up. So there's 1, 2, 3, I think it's 1 through 10, 4, 5, 6, 7, 8, 9, 10. So this is kind of mindless in some sense. I'll do number 7 with you, then not do number 8. So let's work one set at a time. First for 7, I'm going to do A. I'll look inside the A circle. There's 4 numbers there. It looks like there's 1, 2, 4, and 5. So set A is going to be the set containing 1, 2, 4, and 5. I'll move on to set B. I see 4, 5, 7, 8, and 10 inside the B circle. Next, I'll move down to set C. Inside the C circle, I see 2, 3, 4, 7, 8, and 9. So I'm just going to write that. 2, 3, 4, 7, 8, and 9. And now I'm going to fill up the universal set. I think these are the numbers from 1 through 10 again. Let me just make sure. I'll start with 1, and then 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, now we're going to do intersections, union, and complement problems with Venn diagrams. And probably the easiest way to do these is just to create the sets that we need. So if I'm going to do problem 10 with this Venn diagram to figure out what B complement is, would help me if I knew what all the sets were. Set A, I don't think I need here, but you'll need it for number 9, is a set containing A, B, and C. Set B is a set containing C, D, E, and F. And the universe is A, B, C, D, E, F, G, H, I, J. So all the way from A to J. For my number 10, I need B complement. B complement is anything that's in the universal set that's not in set B. So from my universal set, if I take out the 4 letters in B, which is C, D, E, and F, the letters that I haven't marked through are what B complement is. And so B complement is going to be the set containing A, B, G, H, I, and J. For your number 9, your A complement should be D, E, F, G, H, and I. We're going to live with the same sets when we go to do problems 11 and 12. It's the same picture. So I need to find what A union B complement is for my number 12. I'm going to hang on to this drawing here, or these sets. For A, I'm going to replace the symbol A with a set containing A, B, and C because those are the elements of set A. I'm going to keep the union sign, and in place of the symbol for B complement, I'm going to put this set that has A, B, G, H, I, and J. So that would be the set A union B complement written without the letters, written with the sets in their place, using the A that I had from looking at the picture, the B complement that I figured out when I got my answer to number 10. And now I'm going to union these two sets. When I union two sets, I take any element, I take all the elements of the first set, add all the elements of the second set, and then I get rid of any duplication. So I have two A's and two B's, and I write things in a nice order. In this case, my alphabetical is going to be the nice order. And for an answer to problem 12, I'm just going to say the set A union B complement for this Venn diagram is A, B, C, G, H, I, and J. If you've not done your number 11 already, let me write down an answer for, or let me show you an answer for number 11. For number 11, I have C, D, E, F, G, H. I guess that's an I. Yeah, there's no L in this, so that's turned into a capital I and a J. So 14 and 13 want us to do, well, 14 and 13 want us to do the same, use the same Venn diagram, so I'm going to use my same sets. For 14, I need to do the parentheses first. And for the parentheses, I'm going to do A, which is ABC. And then the intersection symbol. And then after my intersection symbol, I'm going to put the set that's equal to B complement, which is A, B, G, H, I, and J. Now I'm going to intersect those two sets. And when you intersect two sets, you find out what the two sets have in common. These two sets have in common the letters A and B. So the inside the parentheses simplifies to the set containing the letters A and B. Unfortunately, I have to find the complement of that. And in order to find the complement, I have to have the universal set in mind. The universal set for this Venn diagram, or the letters contained in this Venn diagram, are all the letters from A through J. So if I want to find the complement of this to finish up this problem for that complement outside the parentheses, the complement of that set is all the letters in the universal set that aren't A and B, so it's going to be the letters C through I. My answer to problem 14, the set that's being described there, is a set containing the letters C, D, E, F, G, H, I, and J. Your problem 13, the answer that I have written down is A, B, D, E, F, G, H, I, and J. 15, we're working with the same picture again, thank gosh. And I want to do A union B complement complement. So in order to start my problem 16, for inside my parentheses, first I'm going to write what the set A is equal to. And set A is equal to the set containing the letters A, B, and C. Then I write my union sign, and then I write what set B complement is equal to. B complement is a set containing A, B, G, H, I, and J. I'm going to union those two sets. And when I union two sets, I take all the elements of the first set, add to it all the elements of the second set, and then I get rid of any duplication. Don't need two A's and two B's. So this set right here, the A union B complement is A, B, C, G, H, I, and J. So that's the inside of the parentheses. Now I need to deal with the complement outside the parentheses. And in order to deal with the complement outside of the parentheses, I have to get that universal set for these problems back up. And that universal set is all the letters from A through J. B, C, D, E, F, G, H, I. And to do the complement of this set, I need to take this set and cross it out from the universal set. And the items that I haven't crossed out will be what's left for the complement. The answer to problem 16 is going to be the set containing the letters D, E, and F, and not C because I crossed the C out. For your problem 15, the answer is just supposed to be the set containing the letters A and B. We have a new pictures for the next 3 or 4 problems anyways. So let's get the sets nailed down here. For this particular next group of problems, set A is going to be 1, 2, 3, 4, and 10. Set B is going to be 4, 5, 6, 7, 9. That's a B and not an 8. So it's 4, 5, 6, 7, 9. And the universal set, I think it's all the numbers between 1 and 10. It might not hurt if I write down what A complement and B complement are, because I might need them. I probably will need them. A complement are all the numbers between 1 and 10 that aren't in this set, and that's going to be 5, 6, 7, 8, and 9. And B complement are all the numbers between 1 and 10 that aren't in this set. So this set is missing the 1 and the 2 and the 3. It has 4, 5, 6, and 7. It's missing an 8, and it's missing the 10. So for these problems, the next handful of problems, these are the sets I'm going to use. For problem 18, I'm doing A intersection B complement. So in place of the A, I'm going to write down the set containing the numbers 1, 2, 3, 4, and 10. And in place of the B complement, after the intersection symbol, I'm going to write the set containing 1, 2, 3, 8, and 10. And intersection is what the sets have in common. These two sets have 1, 2, and 3 in common. My answer for number 18, A intersection B complement, for these sets are the set containing 1, 2, oh, I missed the 10 here. 1, 2, 3, and 10 they have in common. We're going to use these same sets when we do problems 19, 20, 21, and 22. Let me just do 19. Well, 19 and 20 are the same problem, so I'll do 19. 19 wants me to do A complement, which I have written as 5, 6, 7, 8, and 9. Intersect that with B complement, which is 1, 2, 3, 8, and 10. Now I need to find out what these two sets have in common. And as I look at these two sets, I think the only thing they have in common is the number 8. So the answer for this problem is the intersection of those two sets that I have written. The intersection is what those two sets have in common, and that's just the number 8. All right, so 21, 22, I'll do 22, you could do 21. If you don't want to watch me do 22, the answer to 21 that I have written down is 5, 6, 7, and 9. You can fast forward and not watch me do this. For my problem 22, first I have to do the intersection of A and B. A is a set containing the numbers 1, 2, 3, 4, and 10. And B is a set containing 4, 5, 6, 7, and 9. When I intersect these two sets, it's what these sets have in common. What these sets have in common is just the number 4. So I have the parentheses simplified to a single set. Now I'm going to do the complement. The complement of this set is any number in the universal set other than 4. So it's going to be everything, all the numbers between 1 and 10 excluding 4. So it's going to be 1, 2, 3, and then 5 through 10. So the complement of this is going to lead me to my answer. The answer for this is going to be the set having 1, 2, and 3, skipping 4, and then having the skipping 4, and then having the rest of the numbers 5 through 10. Last one with these easy sets. Let me just do 24 with you. So 23 with you, should I say. 23 wants A intersection B complement and then complement. So for 23, I'm going to have my parentheses with a complement, and inside the parentheses I need A, which is 1, 2, 3, 4, and 10, and then intersection B complement, which is 1, 2, 3, 8, and 10. When you intersect, you write what the sets have in common, and these two sets, what they have in common is 1, 2, 3, and 10. So the inside of the parentheses simplifies to the single set containing the numbers 1, 2, 3, and 10. Outside of the parentheses, I needed a complement. To complement this, I take the numbers 1, 2, 3, and 10 away from the universal set, and what I have left is the complement, and that's going to be the answer to this, and it's going to be 4, 5, 6, 7, 8, and 9. So the set that's defined in problem 23 is the set containing the numbers 4, 5, 6, 7, 8, and 9. All right, now we're moving on to the bigger diagrams, the diagrams that have 3 sets. So let me make up an A, which is 1, 3, 4, and 5. Save myself some room for an A complement in a little bit here. A B, which is 2, 4, 5, and 6. Save myself some room for a B complement. C, which is 1, 5, 6, 7, and 10. Save myself some room for C complement. And U, which I believe is all the numbers between 1 and 10. To do the complements, I'm going to write any number between 1 and 10 that's not in the set. So for A complement, I'm going to get a 2 and then a 6 through 10. Those are all the numbers between 1 and 10 that aren't already in the set that we're complementing. For B complement, I'm going to have 1, not going to have 2, it's going to have 3, it's not going to have 4, 5, and 6, and it's going to have 7, 8, 9, and 10. Again, those are all the numbers between 1 and 10 that aren't already in set B. Set C is missing 2, 3, 4, 8, and 9. So set C complement is going to have 2, 3, 4, 8, and 9. And for the next few problems, I'm going to use these sets. For problem 26, the first thing I need to do is A intersection B. And so for the A intersection B, I'm going to take the A set, which is 1, 3, 4, and 5. I'm going to intersect that with the B set, which is a set containing 2, 4, 5, and 6. Don't have enough room to write that union C complement, so I'll deal with it in a bit. A intersection B is what these two sets have in common, and so the A intersection be changed to the set containing the numbers 4 and 5. And now I'll deal with the union C complement. So I have A intersection B replaced with a set containing 4 and 5. I'm going to union that with C complement. I'm going to leave the union symbol, but in place of the C complement, I'm going to write the set containing 2, 3, 4, 8, and 9. And when you union two sets, you take all the elements of the first set, all of the elements of the second set, write them in a big set. So I took the 4 and the 5, the 2, 3, 4, 8, and 9. Get rid of any duplication. I don't need the 2 4s. And now write my numbers in a nice order. So I'm going to go 2, 3, 4, 5, 8, 9. So this is going to be the set containing 2, 3, 4, 5, 8, and 9. And that'll be my answer to problem 26. Definitely going to need these sets as we do 27 and 28. If you want to just do 27 and check yourself, for 27 I have the answer 1, 3, 5, 6, 7, and 10. I'm going to try to do 28. And in 28, the first thing I'm going to do is A intersection B complement. To do A intersection B complement, I take the A set that contains the numbers 1, 3, 4, and 5. I intersect that with the B complement set, which is a set containing 1, 3, 7, 8, 9, and 10. When I intersect two sets, I write what the sets have in common. Those two sets have 1 and 3 in common. So the first thing I'm going to do is replace the A intersection B complement with the set containing 1 and 3. And then I'm going to intersect it with C. To intersect with C, I need to replace the C with what it's equal to. So in place of the symbol for C, I'm going to put the set 1, 5, 6, 7, and 10. And intersections, what they have in common. These two sets only have 1 in common. My answer to number 28 is just the set that contains only the number 1. Unfortunately, only one more with these sets, and then we get some new sets. Let me do 29 with you. So for 29, first thing I'm going to do is A intersection B. Can't see A anymore. But for the A intersection B, A is equal to 1, 3, 4, and 5. I'm going to intersect that with B, which is a set containing 2, 4, 5, and 6. And then in a bit, I'm going to intersect it with C complement. The intersection part of the A and B is what the A and the B sets have in common, which is the numbers 4 and 5. So the A intersection B part can be replaced with a set containing the numbers 4 and 5. And now I want to intersect that with C complement. In place of the C complement, I'm going to put 2, 3, 4, 8, and 9. And now I'm intersecting, so I'm finding what the sets have in common, and those sets have in common the number 4. That's going to be the end of this problem 29. The answer to 29 is the set containing just the number 4. All right, 32 through 39, last set of problems, last picture that we have to get the A's, the B's, the C's, and the U's. So let me try to write down what A complement is, B complement, C complement. A is 2, 4, 6. Let me do it slowly. A is 2, 4, 6, 8, 12, and 20. Probably going to need to know what A complement is, so I'll leave that space there. B is 3, 6, 9, 12, and 15. I'm probably going to need B complement, so I'll leave some space for it. C is 5, 10, 15, and 20. There's nothing outside for the rest of the universal set, which is kind of nice. The universal set's going to be 2, 3, 4, 5, 6. Then I'm missing the 7. Let me start writing this down. It's 2, 3, 4, 5, 6. Misses the 7, has an 8, 9, and 10. And the next number after 10 that I see is 12, 15, and 20. So that's the universal set. To do A complement, I'm going to start going through the universal set, and anything that's not an A I'm going to include. 2 is an A, it won't be part of A complement. 3 is not an A, so it's part of A complement. 4 is in A, it's not part of A complement. 5 is not in A, it's part of A complement. 6 and 8 are in A, they're not part of A complement. 9 and 10 aren't in A, so they're part of A complement. 12's in A, so it's not part of the complement. 15 is not in A, so it's part of the complement. And 20 is in A, so it's not part of the complement. So A complement, if I did this right, is 3, 5, 9, 10, and 15. For B complement, I'm going to go through the universal set one at a time. 2 is not in B, so it's in B complement. 3 is in B, it's not in B complement. 4 and 5 aren't in B, so they're in B complement. 6 is in B, so it's not in the complement. 8 is not in B, so it's part of the complement. 9 is in B, not part of the complement. 10, not in B, so it's part of B complement. 12 and 15 in B, not part of the complement. 20, not in B, part of B complement. Now for set C complement, 2, 3, and 4 aren't in C, so they're part of C complement. 5 is in C, so it's not part of C complement. 6, 8, and 9 are not in C, so they're in C complement. 10 is in C, it's not in the complement. 12 is not in C, it's part of the complement. 15 and 20 are in C, so it's not part of the complement. I believe those are the sets that I need. This is a horrible problem, 32. So for 32, the first thing I want to work on is the inside of the parentheses. And inside the parentheses, I need to do A intersection C. So in place of A, I'm going to put the set containing 2, 4, 6, 8, 12, and 20. And then the intersection symbol, and in place of C, the set containing 5, 10, 15, and 20. When I intersect, I find out what those sets have in common. And what those sets have in common, 2, 4, I think is just the number 20. So A intersection C is going to be replaced with the set that only contains the number 20. Unfortunately, that parentheses had a complement outside of it. So now I need to find the complement of that set, which are all the numbers in the universal set other than 20. So it's going to be all the way from 2 through 15, the numbers in the universal set. So 2, 3, 4, 5, 6, 8, 9, 10, 12, and 15. What a horrible problem. That would be the complement of 20. It's all the numbers in the universal set other than 20. And now I'm going to finish up by unioning with B. So in place of the B, I'm going to put the set containing 3, 6, 9, 12, and 15. When I union these two sets, I write them in a giant set. I take all the elements from the first set. Really regretting this problem. After I have all the elements of the first set, I add on all the elements of the second set. There's my union. I get rid of any duplicate. 3 is duplicated, 6 is duplicated, 9 is duplicated, 12 is duplicated, 15 is duplicated. I get rid of all my duplications, and I write what's left in a nice order. The answer to problem 32 should be the set containing everything but 20. 2, 3, 4, 5, 6, 8, 9, 10, 12, and 15. Horrible problem. Let me do 33 with you just because these are disgusting. So for 33, the first thing I need to do is A intersection B complement. So to start 33, I'm going to figure out what this A intersection B complement is, and then I'll worry about the unioning with C. To do A intersection B inside the parentheses, I find out what A, which is 2, 4, 6, 8, 12, and 20. I find out how to intersect it with B, which is 3, 6, 9, 12, and 15. When I intersect those two sets, A and B, I write what A and B have in common. And what A and B have in common are 6 and 12. So the A intersection B part of this is just going to be the set that contains 6 and 12. Unfortunately, there's a complement outside the parentheses that I need to deal with now. So I'm going to complement this set by taking 6 and 12 from the universal set and writing what's left, which is 2, 3, 4, 5, 8, 9, 10, 15, and 20. So this now, the complement of this set is going to have all the numbers from the universal set other than 6 and 12. So it would have 2, 3, 4, and 5. It won't have 6. It'll have 8, 9, and 10. It won't have the 12, but it'll have 15 and 20. Ugh. And then I'm going to union that with set C. So now I'm going to take this disgusting set, write it again, and write C, which is 5, 10, 15, and 20. So now I'm about to union this set 2, 3, 4, 5, 8, 9, 10, 15, and 20. I'm about to union that with set C, which is 5, 10, 15, and 20. And of course, to union two sets, I write those sets together in a giant set. So I'm going to take all the elements from the first set and then all the elements from the second set. Any duplication I'm going to cross out. There's 2 5s, there's 2 10s, there's 2 15s, there's 2 20s. And I'm going to write down what's left after I get rid of the duplication. This will be my answer to problem 33. It's going to be the set containing 2, 3, 4, 5, 8, 9, 10, 15, and 20. Feel like I've made a mistake, but I could always check. So 33, 2, 3, 4, 5, 8, 9, 10, 15, and 20, it feels good. This has got to be better. Let me do 35. Why don't you try to do 35? See if you can get the answer. 2, 4, 6, 8, 12, 15, and 20. If you can get the answer, don't watch me do your 35. If you can't get the answer, watch me do it. To start with 35, the first thing I need to do is B intersection C. So for 35, it has parentheses. I need to do those first. To do the parentheses, I'm going to write for B 3, 6, 9, 12, and 15. And then the intersection symbol, and for C, 5, 10, 15, and 20. So I'm going to intersect these two sets by finding out what B and C have in common. And what B and C have in common is just the lonely number 15. So the parentheses is going to simplify to just the number 15. Now I want to union that with set A. And so I'm going to replace A with what it's equal to. So I'm going to make this A, which is 2, 4, 6, 8, 12, and 20. And I'm going to union that with the set containing 15. This is a nice union because there's nothing in common. So I'm going to take the first set, followed by the second set. I'd throw out any duplication, but there isn't any duplication. This is an okay answer. As a matter of fact, I don't care to write this again so that the 15 is before the 20. You don't have to write the numbers in ascending order. When I wrote my answer for 35, I see 2, 4, 6, 8, 12, and then 15, 20, I have 20, 15. I don't care if the numbers aren't in ascending order, when it wouldn't be that hard to write it in ascending order, but it's not absolutely necessary. Okay, last two problems. Might as well do the same thing. I'm going to walk through 37 with you. Apparently at one time there was a 39. I don't see a 39 anymore. I must have deleted it because I got tired of doing these. The answer to 37, I believe, is 6, 12, and 20. So try to get 6, 12, and 20. If you can get 6, 12, and 20 for problem 37, then don't watch me do it. You don't need my assistance. You're done with this video. If you can't get it, then I'll do it with you and for you. So for 37, because of the parentheses, I need to do the parentheses first. Parentheses wants B union C. In place of the B, I'm going to put 3, 6, 9, 12, and 15. Then the union symbol, and in place of the C, 5, 10, 15, and 20. When I union those two sets, I get a big set that has all the numbers from the first set, 3, 6, 9, 12, and 15, followed by all the numbers from the second set, 5, 10, 15, and 20, in one big set. And I throw out any duplication. Where's the duplication here? There's 2 15s. And maybe I can write these in a nice order as well. So this is going to give me A intersection 3, 5, 6, 9, 10, 12, 20. I need to leave one of the 15s. I can't cross them both out. So it's 3, 6, 9, 12. One of the 15s, I forgot the 5. How about 3, 5, 6, 9, 10, 12, 15, and 20. Ugh, should have not done this problem, huh? So that is what B union C is equal to. Now I'm going to intersect that with A. For A, it's 2, 4, 6, 8, 12, and 20. So now I'm going to replace A with 2, 4, 6, 8, 12, and 20. And I'm going to intersect it with this set that I just created, the set that contains 3, 5, 6, 9, 10, 12, 15, and 20. And when I intersect two sets, I write what they have in common. Both of these sets have the number 6. Both of these sets have the number 12. Both of these sets have the number 20. They don't have anything else in common. And the answer that I wrote here that's hardly readable, the answer to problem 37 is that 6, 12, and 20 that these two sets have in common. All right, so the next section is a section of word problems with Venn diagrams. It comes in 3 parts. Hopefully I did a good enough job that you feel good about it when you get done with that section. Hopefully this wasn't the worst section. If you knew how to do unions and intersections and complements, then it really wasn't anything new. It's just creating the sets that was the new part. All right, we'll stop right here.